Hi everyone, today we will discuss about constraint relations with strings. These relations are very useful to solve problems based on laws of motion. Now what are constraints? The word constraint means restriction. Restriction. So imagine you and your friend are tied by a rope. Then you both are not free to move any way you want, right? When one of you will move, other one will be also restricted to move in a certain way, isn't it? So the relation between the displacement of you and your friend when you are tied with a string or a rope, the relation between the displacements or the relation between velocities or acceleration, those relations are called constraint relations. Now here we assume the string is inextensible. So the length of the string remains constant during the motion of the blocks connected to the strings. So imagine here is a string and these are the ends of the string A and B. Let's say this end has a displacement x1 towards right. So x1 is the displacement of this end and x2 is the displacement of this end. Now try to think, if this was fixed and this had displacement x1, then what this displacement will try to do? It will try to increase the length or decrease the length. Since this is coming towards B, this displacement will try to decrease the length, right? So the decrease in length we write minus x1. Minus here means the displacement x1 is trying to decrease the length. Now, what about this x2? Well, if this was not moving, what will x2 try to do? x2 will try to increase the length, isn't it? So, the increase in the length will be plus x2. So, this is the decrease in the length. This is the increase in the length. So, the total change in the length will be this summation. And the total change has to be 0. So, minus x1, if I take this side, what do I get? x1 equals to x2. So this is the constant relations between the displacement of the two ends of the string. Now if I take differentiation of this, I will get dx1 by dt should be equal to dx2 by dt, and that will give me velocity of this end must be equal to velocity of this end. If I take one more differentiation, I will get acceleration of this end should be equal to acceleration of this end, right? Now imagine this is the string, the length of this string is constant. This end is having displacement x1 this side and this end is having displacement x2 but not parallel to the string at an angle theta. Then what we should do? Well, this displacement is along the string and it is trying to decrease the length, you can see, right? So this displacement is trying to decrease the length. So minus x1 is the decrease in length. Now this x2 is at an angle. So what we need to do? We need to take components, right? So this component will be x2 cos theta. This component we don't need now. Why? Because this displacement will not try to increase the length also, decrease the length also, isn't it? So this displacement will neither increase the length nor decrease the length. So we don't care about this right now. But this displacement which is along the string, what it will try to do? It will try to increase the length. So the displacement which is trying to increase the length along the string is x2 cos theta. So that should be 0. So x2 cos theta should be equal to x1. Then you can take same relation for velocities, right? By taking differentiation both sides. And same relation for acceleration by taking differentiation of this equation both sides. Okay? So do I mean to say displacement of the two ends of the string should always be same? No. What do I mean to say is displacement of this end along the string and displacement of this end along the string, the component which is along the string, that should be same. Okay. Now let us do some applications of whatever concepts we have learned. Consider these two blocks which are attached to the two ends of a string which is passing over a fixed pulley. So the pulley is fixed. Now I want to know relation between the displacement of these two blocks, and that relation is called constraint relation. Now when I leave the system, the heavier block will fall down and the lighter block will go up. Let me assume this is heavier block. right? Now displacement of this is x2 down and displacement of this block is x1 up. Now how do I find the relation? Well, I will apply string constraint. So you see this length of the string cannot change, right, during the motion. Now consider this point of the string. This point of the string is attached to this block, right? So when this block will have displacement x1 up, this point of the string will also have x1 up displacement, and this point of the string will have displacement x2 down. Whereas if you consider this point and this point, they are attached to the fixed pulley, right? Now look carefully. When this point will have displacement x1 up, it will try to increase this length or decrease this length. Remember, as this goes up, this length will decrease. So minus x1, because x1 is trying to decrease this length, right? You can see. Similarly, this end, if you see here, is trying to increase the length by going down. So plus x2. And these two ends are not moving, right? So that will be total displacement should be 0 because the length of the string cannot change. So from here again we will get x1 equal to x2. So 2 times if you do derivation, you will get a1 equal to a2. And that's why, if you remember, when we discussed Atwood machine, what did we discuss? We discussed that when two blocks are connected like this, then if acceleration of this is a, then acceleration of this is also a in magnitude, right? So the acceleration should be same. Now in complex problems, the technique which I have taught you sometimes takes more time. Therefore there is another way, another technique to get constant relation. So let me explain that technique. You see, this block has displacement x1 up, right? And this block has displacement x2 down. And we know for same string which is massless, the tension should be same everywhere. So show tension on this block T and tension on this block T. Now take the dot product of tension and displacement of the block. Okay, so tension is acting on the block, displacement of the block, take dot product, and the total of that should be 0. So this is what is called virtual work theorem. However, we will not go into the details of virtual work theorem, but I will show you why this is correct, because using this I will get the same relation which I got before. So look carefully. Let me apply this concept here. So you can see tension here is up, displacement of this is also up. So what will be dot product of tension and displacement? T into x1, right? Because in dot product, if you remember, a bar dot b bar is equal to ab cos theta. So if the two vectors are in same direction, theta will be 0 and cos 0 is 1. So since tension and displacement here are in same direction, so the dot product of tension and displacement will be tension into displacement without writing cos theta, because they are in same direction. We have done for this block. Now we have to do for other block and add a summation we have to do. Now for this block, tension is up but displacement is down, so this angle will be 180 and cos 180 is minus 1. So here tension and displacement are in opposite direction. So this dot product will give you minus t into x2. Tension is same, displacement is x2. So that is the total dot product of tension and displacement. And that should be what according to this theorem? 0. Take this plus minus is minus, then you take it that side. You will get tx1 equal to tx2. So t and t will cancel. We will get the same relation which I told you before. Now this is very powerful. I will show you with some examples. But before that, one small thing you need to know. If I have an ideal pulley. Now when I say ideal pulley in physics, it basically means massless and frictionless. Massless and frictionless. So here one string is there and same string goes like this, and here one string is there. If you draw free body diagram of the pulley, then how it will look? Well, how to find free body diagram? I told search for context. So this pulley and this part of the string you take as system. So if you take this part of the string and the pulley as system, then whatever force between this part of the string and pulley will come, that will be internal forces. So that we don't have to show, right? So I am taking the pulley and this part of the string within the system which is in contact with the pulley. Now what forces will act? Well, here one wire is attached to this system, so one tension will be there, T. And here one wire is attached to this, so one tension will be there, T. For same string, same tension. Now here, how much tension will be there? Let us assume T dash. And you know the direction, right? Along the string you have to draw away from the body because it is a pulling force. Now, since I said massless, I will not show mg, right? Now let us assume this whole system is accelerating down or up, it doesn't matter. Now write Newton's law for this pulley. Net force equals to mass of pulley into acceleration. But even if there may be acceleration of the pulley, the mass of the pulley is 0. Therefore, net force on the pulley should be 0. What is the net force? T dash is up, so let us take positive. T is down, minus T. This is also down, minus T, equal to 0. So T dash equals to 2T. Very useful result. So next time, if I show I have an ideal pulley like this, let's say, and here you know tension is T, here tension is T, then here tension will be 2T. Try to remember. Let us apply whatever we have learned to solve this question. So here we have 3 pulley system with 4 blocks A, B, C, D. Their accelerations are given 1, 7 and 2. Units is meter per second square. We have to find acceleration of block D. Okay. So now we will solve this by using the first technique where we know the length of the string is constant, and for each end of the string which is movable we will give some displacement. If the displacement is increasing the length, we will consider plus, and if it is decreasing the length, we will consider minus. Now since the relation between displacement is going to be same as the relation between accelerations, right? So instead of considering displacement, I will do directly with acceleration. So we will first apply the first technique, then only you will see the importance of second technique. So first you consider this length of the string, right? You know that length of the string is fixed, constant. Now this end is moving with the block with this acceleration, and that will try to decrease the length or increase the length. Decrease the length, right? You can see. So minus 1. What about this end? Remember, now this pulley is movable. So if this pulley has acceleration A up, this point will also have acceleration A up. In fact, even this point will have acceleration A up, right? See, if this is your pulley and your pulley is going up with some acceleration, then all these points, including this point and this point, which corresponds to this point of the string and this point of the string, those two also will have same acceleration, right? So what is this acceleration trying to do? You can see it is trying to increase the length, so plus A. What about this acceleration? That is also trying to increase the length, plus A. And this acceleration 7 meter per second square, you can see is trying to decrease the length, right? So the length is getting decreased because of this acceleration, so minus 7. So the total change should be 0. So from here acceleration will come 8 divided by 2, which is 4, because A plus A will be 2A, right? So 2A will be 8, so A will be 4. So that is the acceleration of this pulley. Now look at this string. This string is also inextensible. Now here this pulley is fixed. Therefore, if this pulley is going up with acceleration A, this pulley also should go with same acceleration A down, remember, right? We have seen that already, that if this pulley is fixed, then these two blocks should have same acceleration. If one is A up, other one should be A down. So now consider this length of the string. So you can see because of 2 meter per second square acceleration up, this point will also have same acceleration. So because of that, the length of the string is decreasing, you can see, right? This point is going up. So this length will decrease. So -2. Now this pulley is coming down with acceleration A. So this point of the string will also have A acceleration down. Therefore it is also decreasing length this time, right? Because this end is coming down with acceleration A. So that is also going to decrease the length. So -A. What about this point? That will also try to decrease the length, -A. So this block must have acceleration AD this side, let us say. Then what will happen? This point will have acceleration AD, which we don't know, but we know it is trying to increase the length the way I have shown the direction. So plus AD equal to 0. But A we found already 4, right? So AD must be equal to 10 meter per second square. So that is the acceleration of D. Now, some of you may be wondering in this example, how come this block is also having acceleration up, this also is having up? Some of you think if this is going up, this should go down. But that is only true if this pulley was fixed, remember. This pulley is not fixed, right? So there is always a chance that if you put very heavy blocks here, this is going to go down and this whole thing will go up as seen from ground frame. Remember, all these accelerations are with respect to ground. So from ground frame, since this pulley can go up, it is possible that these two blocks may have acceleration upward as seen from ground. Only if you observe these two blocks from this frame, pulley's frame, then in pulley's frame, pulley will be at rest. So in this frame, these two will have down and up acceleration. But from ground frame, it is possible for both to have acceleration up. So remember that. So now we'll try to apply the second technique where we will take dot product of tension and instead of displacement, I am writing acceleration so that we get directly the relation between acceleration. Okay. First let us show tension everywhere. So this is same string, so same tension, right? So let me write here T, then here also it will be T, right, along the string away from the body. Now I told you, if this is T, here it should be 2T. Now this is same string, so 2T, 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 2T. So here also it will be 2T. Now if it is 2T here, then here it should be half of this. So it will be again T here and T here. Right? Because what did we see before? If this is T, this is T, here it is 2T. Which means if I show here T, then here I should show T by 2. T by 2, yes or no? So here is, because this is T, this should be 2T and the same 2T will come till here. And since here we should have half of this, half of 2T will be T here, right? Okay. Now take dot product here. Tension is up, acceleration is also up. So dot product will be positive. So what will be the dot product? Tension into acceleration. Here you do. Tension and 7 are in same direction. Tension into acceleration. 7, same direction. Here also tension and acceleration are in same direction. Here let me assume acceleration is down. So tension and acceleration are opposites, will be minus tension into acceleration of this we don't know. That should be equal to 0. So take this minus T AD that side. And this 1T, 7T plus 2T. 10T, right? And dt will cancel, so AD will be 10. So you can see in one shot we can find the answer. Just you need to remember how tension is distributed along the strings. Okay? Revise this once, please. Let us see this question. So we have two pulleys, and if nothing is mentioned, please remember these are all ideal pulleys and ideal strings. Ideal pulleys and strings. So massless and frictionless. So here blocks are A and B, and the angle of this inclination is 30 degree. Now we have to find acceleration of this block. First thing is we have to assume the direction of acceleration. So let us assume B has acceleration downwards, AB. And we will assume this block A has acceleration this side, AA. Okay, so AA is the acceleration of block A, which I am assuming this side. Now, you don't have to worry, you assume anywhere. As I told you, if you get positive answer for this acceleration, then wherever you have assumed the direction is correct. If you get negative answer, then the value is still the same, only thing is direction you have to reverse. So if this acceleration comes -2, then the answer is acceleration of this actually is 2 upward, because you assumed down and you got negative answer. Okay. So let us apply Newton's law to block B. So what forces are acting on block B? Here one tension T, here MBG, right? This is the tension, this is the weight. Now since I am assuming acceleration is down, this force should be greater than this force. So net force equals to MA. So net force is MBG minus T equal to MBA. What is the mass of B? 2. So 2 into G will be 20. I am assuming G is 10 meter per second square. Minus tension equals to 2 into A. Equation 1. Now for block A. Now see, this tension T will be everywhere same in the same string. So up to here tension will be T. Now here and here tension will become half of this T, right? I told you that if tension here is T, tension here is T, then tension here is 2T. So if tension here somebody says is T, then here it will be T by 2. Here it should be T by 2, because total force on the pulley should be 0, because the pulleys are massless. So if tension here is T, here tension should be T by 2. So this tension should be T by 2. Okay, so for the block A, let me draw the diagram separately here. So here the tension will be T by 2. Acceleration I am assuming this side. Now since acceleration is this side, I need net force this side. Remember T by 2 is this side. And you should know there will be component of gravity this side, which is mg sine 30. Which m? It is mass of A. Now how this component comes? See this. Suppose you have a block on an inclined plane whose inclination is, let's say, 30 degree. Now we all know gravitational force acts vertically downward. So we can divide this gravitational force into two components like this. Now look carefully. If this is 30 degree, this should be 60 degree, because this angle is 90. And if that is 60, this should be 30. Right? So if this angle is 30, this angle also should be 30. So this component will be mg cos 30, and this component should be mg sin 30, right? Now here why I did not show mg cos 30 is because it will be balanced by your normal force. So write Newton's law for this. Acceleration is this side, so this tension should be greater than this force. So T by 2 minus mag sin 30 should be ma into acceleration of A. This is acceleration of B, remember. Okay. Now, this is T by 2. Mass of A is 4. So this will be 4 into G, 40. Sin 30 is half. Equal to mass of A is 4. Acceleration of A. Let us multiply with 2 both sides, so that this 2 gets cancelled. So T minus 40 will be here. If you multiply with 2, 8A. Now the problem is we have two equations, right? But we have 3 unknowns. Why 3 unknowns? T, one unknown, acceleration of B, acceleration of A. So we will not be able to solve this, because we have only 2 equations, because we have 2 blocks. But we have 3 unknowns. So what to do now? So this is where constraint relations will come. So we will use technique number 2. Summation of tension dot acceleration should be 0 for all the blocks, right? Now for this block you see tension is up, acceleration is down. So angle is 180 degrees. So dot product will be T into acceleration but minus. Right? So if they are opposite direction, the product of these two should have minus sign. for this block, acceleration is here, tension is also here. So plus product will be tension is T by 2 into acceleration of A. So take this one this side, so you will get T by 2 A of block A will be equal to T into acceleration of block B. T will get cancelled. So acceleration of block A is twice of acceleration of block B. So if you substitute this here, right, because I know acceleration of A now, so that will be T minus 40 equal to 2AB. If I substitute here, it will be 16AB. So let me call this equation 3. So now 1 and 3 you can add, right? So add 1 and 3. Here 20 minus 40 will be minus 20. Minus T plus T will cancel. 2 plus 16 will be 18AB. So AB is minus 20 by 18, which is minus 10 by 9 meter per second square. And then if I want now acceleration of A, what was acceleration of A? Remember, it was twice of AB. So minus 20 by 9 meter per second square, right? The minus sign means acceleration of A is actually this side, okay? So A is actually going down the plane. So minus means down the plane. Value will be 20 by 9 only, okay? Let's consider this question. Again, we have two blocks and two pulleys. This pulley is movable, right? Whereas this is fixed. Now, acceleration of A they want, okay? This time what we will do, we will try to find the constraint relation first. So, we don't know where is the acceleration of A. It may be up the plane, down the plane. So, let me assume it is up the plane. Okay? And for B, let me assume it is down. Let's find the relation. We'll apply technique number 2. So let me assume here tension is T this time. So this T, here also T, here also T, right? Same string, right? This is same string, remember? So in same string, same tension everywhere. So here T, then here it must be 2T. So tension here is T on this block, tension here is 2T. So now we will apply our constant relation equation, which is dot product of tension and acceleration should be 0. So for this block, tension is here, acceleration is also here. So same direction means plus tension into acceleration. Here tension is up on this block 2T, but acceleration is down. So minus tension into acceleration of block B. So total should be 0. Take it this side, TT will cancel. So acceleration of A will be twice of acceleration of B. So this is the constraint relation which will be useful for us. Now let's apply Newton's second law. For this block, the total force we have to show 2T already we have shown, and here will be gravitational force 2 mg. So for system B, what will be your net force? Acceleration is down, so 2 mg minus tension, which is 2T. That is the net force downward. That should be equal to, mass is 2m, remember, don't write m by mistake, okay? Mass is 2m into acceleration of B. Everywhere there is 2 common, so you can cancel 2, right? So mg minus t equal to m into AB. This is equation 1. Now apply Newton's law for this system. Here tension is T. Here component of gravity will be mg sine 30, which is mg by 2. And remember acceleration is here, so this T should be greater. So T minus mg by 2, because sine 30 is half, should be equal to mass into acceleration. What is acceleration? AA. So this is your second equation, right? Now remember, we want acceleration of A, so we will substitute for acceleration of B, or no problem, we will put this acceleration here first. So T minus mg by 2 will be m. What is acceleration of A? 2 into AB. So 2 into AB. So let us call this equation 3 after I substituted for acceleration of A in terms of acceleration of B, and for that we used constant relation. Now we can easily solve 1 and 3, right? Add. So if you add 1 and 3, what will you get? Minus T plus T will cancel. mg minus mg by 2 will be mg by 2, right? X minus x by 2 is x by 2. So mg minus mg by 2 is mg by 2. And here MAB plus 2 MAB will be 3 MAB. M cancel, so acceleration of B, 3 if you cross multiply will be G by 6. But we wanted acceleration of A, which is twice of B. And acceleration of B we got G by 6, so it will be G by 3. It came positive, right? So it will be up the plane. So G by 3 up the plane. If G you want to take 10, then it will be 10 by 3 meter per second square, right? So let's try this problem. We have 3 pulleys this time and 2 blocks. Masses I am given equal 2 kg, 2 kg. And everything is ideal here. The string and the pulleys are ideal. Be careful, there are 2 strings attached to this block this time, okay? So first, as you know, we have to assume direction of acceleration, right? So let's assume B has acceleration down and A has acceleration up. If you want to do reverse, you can do it. The final answer will tell you whether you have done the right direction or the reverse one, right? Now let us find relation between these two acceleration using the second technique. So summation of tension dot acceleration should be 0. Let's assume tension here is T. Now you can see this same string, same string, same string. So everywhere tension will be T. Here also T. And here also T. So tension here will be T on this block because this is same string. But this is different string, remember. And here T, so here it must be 2T on this block. Right? Okay. So for this block, if you see, tension is total 3T up. Why 3T? 2T, T in same direction will be 3T total tension. So tension is up, acceleration is up. So dot product should be positive. So plus 3T tension into acceleration. For this block, tension is up, but acceleration is down. So dot product will be minus tension into AB. If you take this one this side, TT will cancel. So acceleration of B will be 3 times acceleration of A. So try to remember this. This is your constant relation, right? Now apply Newton's law to this block, block B. So here tension is T, here mg will be 2 into g, right? Mass is 2. Acceleration is down, so this force should be greater. So 2g minus t should be 2 into acceleration of B. This will be 20 minus t equal to 2 into, let's substitute for AB here only. So this will be 3 into AA. So 20 minus t equal to 6 acceleration of A. Now let us apply Newton's law to system A. Acceleration is up, so tension here will be more than the weight. What is the weight? 2g. So net force is on this 2 kg block is 3t is up, 2g is down. So that's the net force. Tension minus weight. That should be equal to mass of this is 2 into acceleration. Right? Now we need to simplify these two equations. Right? Two unknown, two equations T and AA. To simplify this, let us make this also coefficient same as this. This is 3t, let us make this also 3t. Right? So what we can do is this equation, let us multiply with 3. What will I get? 60 minus 3t equals to 18a. Then we will add with this. So if you add these two now, if you add, what will you get? 60 minus 2g means here 20 I can write, no? So 60 minus 20 will give you 40. Minus 3t plus 3t cancel, and that side 18 plus 2, 20. So this will give you finally acceleration of A is equals to 2 meter per second square. Now if acceleration of A is 2 meter per second square, acceleration of B will be 6 meter per second square. Quite simple, right? Let's try this question. So here is a smooth ring which can slide on this rod which is fixed between these two supports. Okay, so this is a rod which is fixed between these two supports. and this is a ring which can slide on this. It's a frictionless ring. Okay, there is no friction here, and this string is connected to this ring, and that string goes over this pulley and is connected to this block whose mass is m by 2 and ring's mass is m. So ring's mass is m. We need to find acceleration of the ring initial. Initial, why? Let me explain. So we have to calculate initial acceleration of ring. Why initial? Because with time this angle will change. So after some time this ring will come here. So this angle will change, right? So at this moment when the angle is 60 degree, what is the acceleration of ring? That we have to calculate. Now obviously you know that since the ring is restricted to move along this road, its acceleration will be this side. So let me call it A1. So A1 is acceleration of the ring, and this block has acceleration A2 downside, let me assume. Now first we will derive the constant relation. Remember here tension will be like this along the string away from this body. So this is your T. Same string. So here tension will be same only, right? So what is tension into acceleration here? Dot product T A1 cos 60. Why cos 60 this time I have used? Because acceleration and tension are not in the same direction. And remember, we have to take dot product of tension and acceleration. And we all know in dot product A bar dot B bar we get AB cos theta, cos. And theta is obviously angle between A and B, right? So angle between tension and acceleration for this ring is 60 degree because acceleration is along the rod, tension is along the string. And what about this block? Tension is up, acceleration is down. So minus tension into acceleration. So this should be 0. If you take this side, TT will cancel. So A1 cos 60 is half equals to A2 cross multiply. A1 will be twice of A2. So that is our constraint relation. Now apply Newton's law to this. M by 2G is the weight. Acceleration is down. So let's use Newton's law for this block. Net force should be Ma. Acceleration is down, so net force should be down. So this force should be greater than this. So total is M2G by 2 minus tension. Right? Mg minus tension. M is M by 2 equal to mass is M by 2 into A2. Please don't forget to write M by 2 because mass of this block is half of the mass of the ring, remember. So I can multiply with 2. So this is mg minus 2t equal to ma2. Okay. Now let us go for the ring. For the ring, remember acceleration is this side. So there will be some normal contact force here, right? M will be here. Friction is not there, remember. So which force is creating this acceleration? It is very clear that normal force will have no component here. So there an mg will be here. Mg also will have no component here. So which force is this side? Of course the component of this tension, right? So this T will have one component here, T cos 60, other component here, T sin 60. And this normal must be balancing T sin 60 plus mg because vertically there is no acceleration. But we are not interested in that, right? So horizontally, who is giving this A1 acceleration? Remember the force in this horizontal direction cannot be normal and mg because normal and mg are along y-axis. Vectors along y-axis do not have x component. So the only force along this direction is your T cos 60. So T cos 60 should be equal to mass of the ring into acceleration of the ring. And cos 60 is half, so T by 2 equal to ma1. Let me multiply with 2 both sides, so T will be twice ma1, right? So now let us substitute this tension here because our job is to find acceleration of the ring. So put this tension here. So what will you get? Mg minus 2, tension is 2ma1 equals to ma2. And what is a2 from here? a1 by 2. a1 by 2. Remember, our aim is to find a1, which is acceleration of the ring. M common and cancel, so it will be g minus 2 into 2, 4a1, you take that side. So 4a1 plus a1 by 2. So this will give you g equals to, take LCM 2, 4 2s are 8, 8 plus 1, 9, a1, right? So from here, if you cross multiply, a1 will be 2g by 9, and that is the acceleration of the ring, right? Let us now try this question. So we have a system with two pulleys. You can see this pulley is fixed and this pulley is movable, and three blocks of equal masses 2 kg, 2 kg, 2 kg are attached to these strings. Now you can change one of the mass and see how the answer changes later. Okay. Now we have to find the acceleration of the three blocks. So the first thing we have to do is we have to assume the direction of acceleration of the three blocks. So let me assume A has acceleration up, B let us assume up, and C I will assume down. Just blindly I have assumed. Okay. Now let's apply Newton's second law to block A. So here let me assume tension is T, then here gravitational force, which is weight, mg, mother's love I call it, right? Now the net force on A should be m of A into A of A, mass of A into acceleration of A. What is the net force? Tension is up minus mg is down, and that should be mass of A into acceleration of A. Why I took tension first? Because acceleration is up, so tension should be greater than mg because net force should be up. So T we don't know, mass of A is 2, g is 10, so this is 20, 2 into acceleration of A, right? Let us now apply Newton's law to block B. So here is your block B, but remember this tension here will not be T because this string and this string are not same. So for the same string, tension will be same. So here tension will be T. And what did we learn? If tension here is T, here and here it will be T by 2, T by 2, right? So here since acceleration is assumed up, tension must be greater than weight. What is the weight? mBg. So net force on block B will be tension, which is T by 2 minus weight, and that is mass of B into acceleration of B. Now what is the mass of B? 2. So 2 into G, 20, 2 into AB. Let's multiply with 2 because I don't want this 2 in the denominator. So this will become T minus 40 equal to 4AB. Equation 2. Now do the same thing for system C. But for system C, remember I have assumed acceleration down. So mcg, the gravitational force, should be more than the tension. So mass into g, weight, minus tension, T by 2 should be equal to mass of C into acceleration of C. So 20 minus T by 2 equal to 2AC. Let's do the same thing, multiply with 2, so 40 minus T equal to 4AC. Now, if you notice, you have how many unknown? 1, 2, 3. And then tension has 4 unknown, right? So total we have 4 unknowns, but we have 3 equations. So clearly we need one more relation. And that relation is what we call constraint relation, right? So that's why these relations are very useful. Now to find this relation, I will use the second technique because it is easier. So what I should do? Take summation of tension dot acceleration for all the blocks, add them, total should be 0. For this block, tension is up, acceleration I have assumed up only. So dot product will be positive, T into acceleration of A. For this block, tension is up, acceleration is again up only. So positive only, tension is T by 2 but. And for this block, tension is up but acceleration is down. So minus, tension is T by 2, acceleration is AC. So that should be 0. Now you can see T is common. So if you take T common and divide 0 by T, again you will get 0. So acceleration of A will be what? Take AB by 2 this side, AC by 2 that side. So AC by 2 minus AC by 2 when it goes that side will become plus AC by 2. AB by 2 when it goes that side will become minus AB by 2. So acceleration of A will be AC minus AB divided by 2. So that's my constant relations. Okay. Now solving this is very easy. Don't worry. Okay. So let me write this constant relation like this: 2 acceleration of A, acceleration of C minus acceleration of B. Now 2 into, how to find this acceleration? Look at here. From here, tell me what is acceleration of A. T minus 20 divided by 2. T minus 20 divided by 2. Acceleration of C is what from here? 40 minus T divided by 4. 40 minus T divided by 4. Minus, better to put bracket because there is a minus sign. And for acceleration of B from here, what it will be? T minus 40 divided by 4. Right? So easily you can simplify these two and these two will cancel. T minus 20. Here you can take 4 LCM, 40 minus T minus minus plus 40. Cross multiply 4T minus 4 into 20, 80. 40 plus 40, 80 minus T minus 2T. When minus 2T will come here, 4T plus 2T will be 60. And minus 80 will go there, 160. So tension will be 160 by 6. And that would be 80 by 3 Newton. Right? So once we know tension, now acceleration of the 3 blocks easily we can find from here. So acceleration of block A will be half of T minus 20. So half of T is 80 by 3 minus 20. So this will be 3, 80 minus 60. 80 minus 60 will be what? 20 by 2 3s are 6. Which is 10 by 3 meter per second square. So this is acceleration of A.